Okay, let's examine this question. This is a device that is being used in many countries, right, to give warning if the drainage or reservoir reach a certain dangerous water level. So they say that this is a simplified flood warning system. Part P is exposed to the surrounding. That means this is open. And part Q is covered with a plastic container. So when rainwater flows into part P, the buzzer would go off. Okay, go off means it activated, the alarm is sounded to warn of a possible flood. Okay, take note, you have to explain how a heavy rain can cause the buzzer to go off. So you can annotate this part. So imagine there's heavy rainfall, right? That falls onto this open part. So the water level would increase, right? Because you see this part, right? Is the water from here will flow through there. And one of the property of water is, or liquid, it does not have a definite shape. Okay, so this water level here and must be the same level. Okay, so if the water level continues to go up, okay, notice this part, styrofoam. In fact, here is white color. So if you color it with gray color, maybe more visible. Okay, this part. So there's a styrofoam here. The styrofoam is able to float on water. Okay, so there's a piece of styrofoam, and styrofoam can float on water. So as the water level increases, right, the styrofoam would move upwards. Okay, and then there's a thin metal sheet, right, on top of the styrofoam. So you can imagine if the water level increases, right, upwards, right, to a certain time, the metal sheet will form a closed circuit with the metal contact. Okay, so this part will increase, will go up, and this will form a closed circuit. And the current, the electricity from these two batteries will go through this circuit, will turn on the buzzer. So you must explain the theory behind this. So how do you explain? Okay, this is a 2-mark questions. So let me see if the lines are sufficient. Okay, yeah, there are 2 lines there. So you should say that when water flows into part P, it will cause the water in part Q and the styrofoam to rise. Okay, when the metal sheet on the styrofoam touches the metal contact, it will form a closed circuit. Electricity can pass through the buzzer, cause it to go off. Okay, so this part I will guide you to write. So you say when water flows into P, make it short form, it causes the water in Q and the styrofoam to rise. Okay, cause the styrofoam to rise. Okay, when the metal sheet, okay, make it smaller, this part, otherwise, when the metal sheet on the styrofoam is styrofoam, STY. Okay. When the metal sheet on the styrofoam or the F-15 fighter jet fly past, when the metal sheet on the styrofoam touches the metal, touches the metal contacts, okay, a closed circuit is formed. A closed circuit is formed. And electricity can pass through the buzzer to cause it to go off. Okay, this part. Okay, so when the water flows in part P, it causes the water in part Q and the styrofoam to rise. When the metal sheet on the styrofoam touches the metal contacts, a closed circuit is formed. Electricity can pass through the buzzer to cause it to go off. So this is a 2-mark question. So this is how the examiner will mark. So firstly, you must mention that it will cause the water and styrofoam to rise, this part. And then the metal sheet form a, can metal sheet touch the metal contact, a closed circuit is formed. Electricity can pass through. So this is how the 2 marks are being awarded. Okay, so you take note of this. I will do a screenshot and then send the answer over shortly. Okay, next part. Okay, next part. Okay, this is another questions. Okay, diagram 2 is here. Okay, and diagram 3 is the next page. Okay, so diagram 2 and diagram 3 shows different ways of connecting these 5 bulbs. Okay, in different parts of a house. So you take note that this is a bedroom, and then this is a living room. The dotted line represent the walls. Okay. So the question is on the following page. So does it mark a cross on diagram 2 to show the position of a switch that controls B2 in the bedroom only? So this is a B2, right? Can you see? So it's very easy. I just want to put a switch, right, that controls B2 only. So you can put a switch here visibly. Okay, put a switch here. Put a cross X. So it can be on here and on here, either way. Just one switch, either here or here. Okay, so I prefer to put it here. And then next question, compare diagrams 2 and 3. Which electrical circuit will make the room to appear brighter? Okay, the room means the living room. Okay, the room actually here, they didn't say, is it bedroom or a living room? Make the room appear brighter. Okay, never mind. Actually, I think it's both rooms. So if you observe in this circuit here, this whole thing here, okay, you will notice that these 5 bulbs are connected in parallel, right? Because this is the power source. Okay, this is the power source. So if any of the bulb is not working, they won't affect the rest. So this one, you can annotate here. These bulbs are connected in parallel. Okay, by the side here, you can annotate here, connected in parallel. And then here, if you notice, these 5 bulbs are connected in series, correct? So if you learn in theory, right, bulbs connected in parallel will be brighter, right, than those connected in series. So the answer is very obvious. So they say, which electrical circuit arrangement will make the room brighter? So it's actually this one, okay? The arrangement in diagram 2. Okay, then you need to explain, right? Explain your answer. So you should say that bulbs connected in parallel will shine brighter than those bulbs connected in series. Okay, so for this question, you say, okay, they compare which, okay, the circuit in diagram 2. Okay. The circuit in diagram 2 will make the room brighter. Okay, then the explanation. Bulbs connected in parallel, P-A-R-A, will shine brighter. Will shine brighter than bulbs connected in series. Okay, this is the theory part. So this is the answer for this. I will do a screenshot. So, okay, next one. Okay, let me send over this one first. Before I continue, I will pause the recording. Okay, let's continue the next part. Okay, the diagram below shows 5 identical bulbs arranged in a hall. Draw 2 switches using X. Okay, draw 2 switches using X, such that when the switches are open, only bulb S and T remain lit. So this is S, right? This is T. Okay. So you're supposed to draw 2 switches using X, such that when the switches are open, okay, that means the switch will not affect these 2 bulbs. So that means the switches should not be on the path where the current flows through the S and T when they're open. Okay, only because can you see the word only? Okay, and also this is only. So I want to place. Okay, can you see there's one possibility here? So when this is open, right, because the current will go through here, and then I put another one here. Okay, so this is one possible answer. So how to check? You see, so this is a power source. Okay, maybe I use another color. I use red color to show clearer. So this is the power. There are 2 batteries connected in series. So the current will flow through here. Can you see? They are not affected by the 2 switches, even they are open. Okay, even when they're open. So this is one possible answer. You can also put the switch instead of this side, you can put it on the other side. Okay, you can also put it on here. Okay, so this switch can be on this side as well. So this is one possible answer. Okay, next, state all the bulbs, they will have the same brightness as Q. Same brightness. Okay, let me erase everything and then discuss as Q. So where is Q? So you notice Q is here. Okay, so which are the bulbs that will have the same brightness as Q? Okay, now you assume there's no switch here because that means the whole thing is a closed circuit. Okay, you notice, right? The power source is here. Okay, so can you see Q, P, S, right, and T, right? They are actually connected in series. I repeat, Q, P, S, T, they are connected in series. Okay, because if they're connected in series, means these 4 bulbs, right, will have the same brightness. So the answer is very simple. It's the remaining 3. So you just put P, S, and T. Okay, so these 3 bulbs will have the same brightness as Q. Which of the bulb will continue to lead, right? If bulb F is fused. So I erase this. So if bulb S is being fused. So S, let's say this color. If this is not working, right? So can you see this one can be turned on? Because the current flows through here. Only this one cannot. Only T cannot, right? The rest can, right? So it's PQR, very easy. So it's P, Q, and R. Okay, if will bulb P light up if Q is fused? So no, right? Because it's on the same line. So answer is no, because bulbs P and Q are connected in series. So when bulb Q fuse, it creates an open circuit. So no electric current will pass through P. So this one you answer. This one is a 1 mark question, although it's a 1 mark, but you need to give explanation. So you say no. So you say bulbs P and Q are connected in series. When bulb Q is fused, comma, it creates an open circuit. Okay. So no electric current, no electricity, or no electric current. No electric current can pass through bulb P. Okay. So this is the answer for this page. Okay. So I will save this and send over. Okay. And pause the recording first.